Tonight, we're going to explore gravity. This is not something you need to understand all at once. It is a force that has been with you since your first breath, yet it remains one of the most profound mysteries in the known universe. You don't need to remember every detail or follow every calculation. You can simply listen and allow your thoughts to drift as we move slowly outward from the ground beneath you to the edges of what we can perceive. Gravity is often described as a pull, a tether, or a weight. But as we will see, it may be something much more subtle. To begin, let's start with something familiar. Imagine the room around you right now. Everything in it is participating in a silent, invisible dialogue. The chair, the walls, the very air, all of it is anchored by a presence that we rarely stop to acknowledge. We speak of gravity as if it is a thing, like a rope or a magnet, but it is perhaps better understood as the shape of the stage itself. It is the architecture of reality. Scientists have spent centuries trying to pin down its essence, moving from the simple observations of falling fruit to the complex mathematics of warped dimensions. Yet, even the most brilliant minds feel a sense of gentle humility when faced with its persistence. Historically, we have tried to make sense of this through humor and metaphor. In the 17th century, the great thinkers were trying to understand why we didn't simply fly off into the void as the Earth spun. There were theories of invisible hooks and ethereal winds that kept us pinned down. It is a comforting thought. In its own strange way, the idea that the universe has a vested interest in keeping us exactly where we are. But as we peel back the layers of our understanding, we find that gravity is not a force that is applied to us, but a condition we inhabit. Think of the immense scales of time that gravity has governed. Long before the first humans looked up at the moon and wondered why it stayed aloft, gravity was already at work, quietly gathering clouds of hydrogen in the dark. It is the most patient sculptor in existence. It takes millions of years to fold a nebula into a star, and billions of years to organize those stars into the spiraling arms of a galaxy. It never tires. It never fluctuates. It is the steady, low-frequency hum of the cosmos. As we drift deeper into this exploration, we will move beyond the common misunderstandings. We will see that gravity is not just about things falling down, but about the very way that space and time are woven together. It is a journey from the weight of your own body to the weight of entire clusters of galaxies. But for now, there is no need to rush. There is no urgency to solve the puzzle. The universe moves at its own pace, governed by rules that are as ancient as they are mysterious. We are simply here to observe, to listen, and to slowly let go of the day's demands. The ground is steady, the stars are in their places, and the force that holds them is holding you too. If you enjoy these deep explorations in space, consider subscribing or hitting the like button. It really helps the channel grow and allows me to make content like this. When we think about gravity, we often imagine it in human terms. The weight of a heavy book in your hand, the way your feet press into the floor, the predictable path of a glass if it should happen to slip from a table. For thousands of years, we viewed gravity as a simple domestic rule, a law of the household. If you were a person living 500 years ago, gravity was just the downness of the world. It was the reason the rain fell and the reason your tired bones felt heavier at the end of a long day's work. Consider the simple act of sitting in your favorite chair. You feel a gentle, persistent pressure against your back and legs. We call this weight, but in reality, It is a constant conversation between your body and the mass of the entire planet beneath you. To a scientist, you are currently experiencing an acceleration of 9.8 meters per second squared, but to your mind, it is simply the feeling of being home. It is the most reliable sensation we possess. From the moment we learn to crawl, we are negotiating with this invisible partner. Every step you have ever taken was a calculated defiance of the Earth's desire to keep you still, and every time you rest, you are simply surrendering to that same quiet request. In the historical mind, this was not a mathematical equation, but a moral one. Ancient scholars, from the sun-drenched halls of Alexandria to the cold stone monasteries of medieval Europe, looked at a falling stone and saw purpose. They believed that objects were endowed with a kind of internal longing. A stone was made of earth, so it naturally sought the earth. Smoke was made of air and fire, so it naturally sought the heavens. It was a universe of belonging, where everything had a natural place it was trying to return to. There is a certain humor in imagining a rock feeling homesick, or a raindrop feeling a sense of duty to the soil. But this perspective kept the world feeling small and purposeful. It was a human-scale explanation for a cosmic-scale phenomenon. To a person living in the year 1300, the idea that the Earth was pulling on the moon would have seemed absurd. Why would the heavens care about the mud? The sky was a realm of perfect circles and divine mechanics, while the ground was the realm of heavy, imperfect things. Gravity was local. It was the reason your soup stayed in the bowl and the reason the thatch stayed on your roof. It was a domestic force, as predictable as the seasons and as intimate as your own breath. We didn't need to understand the curvature of space-time to build cathedrals. We only needed to know that if a stone was placed incorrectly, it would find its way back to the grass. As we move through our lives, we carry this local understanding with us. We feel it in the way a blanket drapes over our shoulders at night, settling into the curves of our bodies. We feel it in the resistance of a staircase. We even feel it in our biology. Your heart is a pump designed specifically to fight gravity, pushing blood upward toward your brain against the constant, silent pull of the planet. If you were to leave this pull, your body would slowly begin to drift, not just physically, but biologically. Your bones would soften, your muscles would relax, and the very fluid in your inner ear, the liquid that tells you which way is up, would lose its meaning. We are, in a very real sense, creatures made of gravity. Even our language is heavy with this force. We speak of weighty decisions, falling in love, or feeling grounded. We describe someone who is serious as grave. We have internalized the physics of the earth into the physics of our souls. This comparison isn't perfect, of course. It suggests a psychological depth to a force that may be nothing more than the geometry of a vacuum, but it gives us a calm place to begin. Before we can understand the terrifying density of a black hole or the vast expansion of the cosmic web, we must first appreciate the quiet, steady work gravity does in the kitchen, in the garden, and in the bedroom. Imagine for a moment that this force was not constant. Imagine if gravity flickered like a faulty light bulb. One moment, you are tucked safely into bed, and the next, the tension of the world relaxes, and you find yourself hovering inches above your mattress. The cat drifts toward the ceiling. The water in your glass forms into perfect, trembling spheres. It sounds like a dream, but it reminds us how much we rely on the stubbornness of the world. Gravity is the ultimate conservative. It hates change. It wants things to stay where they are, or to move toward the center in the most direct way possible. In the 1600s, this domestic peace was gently disturbed by a man sitting in an orchard. We've all heard the story of Isaac Newton and the apple, but the real humor lies in the realization that hit him. He didn't just discover that things fall, he discovered that things fall everywhere. He realized that the same downness that brought the apple to the grass was the same force holding the moon in the sky. It was a scandalous idea at the time. It suggested that the mundane, heavy laws of the earth also applied to the bright, celestial lights of the heavens. It bridged the gap between the mud and the stars. But even Newton, with all his brilliance, he found the mechanism of gravity to be a bit spooky. He could calculate how it worked with incredible precision, enough to predict the return of a comet or the timing of the tides, but he couldn't explain how it did. One out. How does the Earth reach out across thousands of miles of empty space to grab the moon? There are no ropes, there are no chains. Newton himself called it action at a distance, and he admitted that he found the idea quite baffling. It was as if the universe was performing a magic trick that never ended. To the people of his day, this was both enlightening and deeply unsettling. It meant we were no longer living in a small, enclosed house with a solid floor. We were living on a ball of rock, spinning through an abyss, held in place by an invisible, ghostly hand. But gravity doesn't care if we find it unsettling. It continues to function with a flat, mechanical indifference. It doesn't matter if you are a king or a peasant. The Earth pulls on you with the same 9.8 meters per second squared. It is the great equalizer. Think of the energy required to lift a single bucket of water from a well. You feel the strain in your shoulders, the tension in your back. That strain is you experiencing a direct physical encounter with the mass of the Earth. You are fighting the collective pull of 6 sextillion tons of rock and iron, and yet we do it every day without thinking. We lift our children, we carry our groceries, we climb hills. We are constantly engaged in a low-level struggle with the planet, and yet the planet never loses its patience. It never lets go. This scale, the human scale, is where gravity is most real to us. It is the scale of 1 to 1, one person, one planet. It is the reason we have a sense of down at all. In the vastness of interstellar space, down ceases to exist. There is only toward and away from. But here, on this gentle curve of rock, we have the luxury of a floor. We have the luxury of knowing that if we put our shoes down at night, they will be there in the morning. They won't have drifted to the ceiling or wandered into the hallway. As you lie there now, consider the sheer reliability of this. The universe is a place of immense chaos. Supernovas are exploding, galaxies are colliding, and space itself is stretching. But here, in your room, gravity is keeping the peace. It is holding the atmosphere against the glass of your window. It is keeping the blood in your veins flowing in the right direction. It is a silent, invisible caretaker that never takes a holiday. Scientists understand this domestic gravity by measuring the tiny variations in its strength. Did you know that gravity is slightly weaker at the equator than at the poles? Or that it is slightly stronger over a mountain made of dense ore than over a valley of sand? If you were to stand on the scale in different parts of the world, your weight would change by a fraction of a percent. You wouldn't feel it, but the Earth knows. The Earth is not a perfect sphere. It is a bit lumpy, a bit squashed, and its gravity follows those lumps and bumps with meticulous accuracy. But even with everything we've learnt at this scale, there is a lingering mystery. Why is gravity so much weaker than the other forces? Think about that paperclip again. The entire mass of the Earth, all the mountains, the oceans, the iron core is pulling on that tiny piece of wire, and yet you can pick it up with the smallest flick of your finger. You, a fragile collection of water and carbon, can easily defeat the gravitational pull of a whole world. This suggests that while gravity is the most visible force in our lives, it is actually the weakling of the physics world. It is pervasive, but it is thin. This thinness is what allows for the complexity of life. If gravity were just a little bit stronger, our bones would have to be as thick as tree trunks to support us. If it were a little bit weaker, the atmosphere would have escaped into space long ago, leaving the Earth as dry and silent as the moon. We live in a Goldilocks zone of gravity, not too heavy to crush us, not too light to lose us. It is a perfect, subtle balance that has persisted for billions of years. As we begin to drift away from this human-scale perspective, keep this feeling of weight in your mind. It is your anchor. No matter how strange the universe gets, no matter how much we talk about time, slowing down, or space bending like a piece of rubber, it all comes back to this: the feeling of your feet on the floor, the weight of the book in your hand, and the quiet, certain knowledge that the Earth is holding onto you. And for now, that certainty is simply part of the picture. It doesn't need to be analyzed or quantified to be felt. It is a foundational truth of your existence. You can trust it. You can lean into it. With that in mind, let's move outward once more, past the roof of your house, past the clouds, and past the thin blue line of the atmosphere to an even larger scale. As we rise, the familiar sensations of the ground begin to shift, yet the underlying principle of gravity remains as steady as your own heartbeat. Imagine looking back down from a height where the houses look like tiny toys and the rivers look like silver threads woven into the green fabric of the land. Even at this height, gravity is the invisible hand reaching up to keep you connected to the world below. It is the tether that ensures that no matter how high we soar, we are never truly lost to the abyss. In the history of human thought, there was a time when we believed the air itself had a weight of its own, a sea of air that pressed down upon us. Torricelli, a scientist of the 17th century, mused that we live at the bottom of an ocean of element. It is a humorous image ourselves as deep-sea creatures of the atmosphere, scuttling along the floor of a gaseous trench. This atmospheric pressure is merely gravity's way of hugging the gases close to the Earth's surface. It is a domestic, human-scale gravity that allows us to breathe without thinking. It is the reason the clouds don't simply float away into the blackness of space, but instead linger, drifting lazily like sheep in a celestial pasture. Consider the birds. We see them as the ultimate symbols of freedom from gravity, yet every flap of a wing is a direct engagement with the Earth's pull. They are not escaping gravity, they are dancing with it. They use the air held down by gravity to push themselves up, creating a beautiful, temporary balance. But even the strongest eagle eventually returns to the nest. Even the highest flying jet eventually seeks the runway. Gravity is the ultimate host. It always welcomes you back. As we move past the thin blue line of the atmosphere, we enter a realm where the human scale begins to stretch. In the early days of ballooning, explorers were terrified that once they reached a certain height, the Earth would simply let go. They feared a point in the sky where gravity would vanish like a mist, leaving them stranded in a silent, weightless purgatory. There is a gentle, historical irony in this fear. We now know that gravity doesn't have an edge. It doesn't simply stop. It merely thins, like a perfume fading as you walk away from the flower. Think of the International Space Station, orbiting just a few hundred kilometers above the surface. We often see videos of astronauts floating, seemingly free from the Earth's grasp. We call it zero gravity, but this is a human-scale misunderstanding. At that height, the Earth's gravity is still 90% as strong as it is on the ground. The astronauts aren't weightless because gravity is gone. They are weightless because they are in a state of perpetual falling. They are falling around the Earth at such a speed that the ground curves away beneath them as fast as they drop. It is a state of constant motion that feels like stillness. This is the bridge between our world and the cosmic world. It is a place where the domestic rules of the household begin to blend into the grand geometry of the stars. You can imagine the Earth as a massive silent bell, and gravity as the sound it emits, a sound that grows quieter as you move away, but never truly disappears. Scientists understand this transition by measuring the escape velocity, the speed you would need to travel to break free from the Earth's primary well. It is about 11 kilometers per second. It is a number that defines the limit of our planetary cage. But even when you reach that speed, the Earth's ghost still tugs at your sleeve. You carry the signature of your home planet with you in your trajectory. As you lie here, imagine your own perspective widening. You are no longer just a person in a room, but a passenger on a craft that has just cleared the clouds. The air is thinning, the stars are becoming brighter and more constant, and the horizon is beginning to curve. The weight you feel on your bed is the same weight that keeps the space station in its loop. It is the same weight that keeps the atmosphere pressed against the mountains. It is a single, continuous velvet curtain that wraps around the entire world. There is no urgency in this ascent. The transition from the human scale to the planetary scale is as smooth as a dissolve in a dream. We don't feel a sudden snap or a change in state. We simply move from the local to the universal. The down of your bedroom becomes the inward of the planet. The weight of your body becomes the mass of a celestial object. Historically, this transition was the great hurdle of the human imagination. To move from the flat Earth of our daily experience to the spherical Earth of the cosmos required a leap of faith in the consistency of gravity. We had to trust that the force holding the water in a well in London was the same force holding the water in a well in a land we had never seen. It is a trust that has never been betrayed. Gravity is the most honest thing in the universe. It never lies about its presence. It never changes its mind. In the deep drift of this perspective, we see that our human lives are small, but they are not disconnected. Every time you drop a pen or watch a leaf fall, you are witnessing a cosmic event. You are seeing the same law that governs the collision of galaxies acting on a small wooden table. It is a humbling and yet comforting realization. The universe is not a collection of separate pieces. It is a single, folded fabric, and you are tucked into one of its most comfortable folds. And for now, that certainty is simply part of the picture. It doesn't need to be analyzed. It doesn't need to be measured. The earth is beneath you. The sky is above you. The pull is constant. The rest is inevitable. With this grounded feeling, we are ready to leave the atmosphere behind entirely. We are ready to look at the earth not as a flaw, but as a marble, and to see the gravity not as a weight, but as a path. Now let's slowly expand outward. One level beyond what we just explored lies the scale of the planet itself. To understand gravity here, imagine the Earth not as a solid, unchanging sphere, but as a massive indentation in the fabric of the world. If you were to walk across the surface of the Earth, you would cover about 40,000 kilometers to return to where you started. Every inch of that journey is governed by the mass beneath your boots. But to truly see the scale of a planet, we must stop looking at the ground and start looking at the space the ground occupies. Imagine for a moment that the universe is not an empty void, but a vast, invisible sheet of fabric, smooth, silent, and perfectly flat. Now, imagine placing the Earth onto that fabric. The Earth is heavy. It is made of iron, nickel, silicate rocks, and deep, vast oceans. Its weight, nearly 6 sextillion tons, causes the fabric of space to stretch and sag. It creates a well, a curve that slopes inward from every direction. This is the indentation we speak of. When you drop a ball, it isn't being pulled by a magical magnet in the dirt. It is simply rolling down the invisible slope created by the Earth's presence. Gravity, at the planetary scale, is not a force that happens on the world, but a shape that happens because of the world. Scientists understand this planetary gravity by observing how it holds the moon in a steady, silent embrace. The moon is roughly 380,000 kilometers away, a distance so vast that if you were to drive there at highway speeds, it would take you nearly 5 months of continuous travel without a single stop for fuel or rest. Yet, gravity bridges that gap instantly and continuously. The moon is essentially a marble rolling around the rim of the Earth's gravitational well. It wants to fly off into the dark, straight into the abyss, but the curve of space created by the Earth keeps nudging it back, forcing it into a circle. It is a perpetual fall that never hits the ground. What we know so far suggests that this curvature is not limited to the solid Earth. It extends to the very air we breathe. Gravity is the reason the Earth has an atmosphere at all. Without this planetary anchor, the nitrogen and oxygen molecules that sustain us would simply drift away, wandering off into the vacuum like smoke in a breeze. Gravity acts as a gentle, invisible lid, keeping the life-giving gases pressed close to the surface. It is the reason that as you climb a high mountain, the air becomes thin. Gravity is huddling the molecules as close to the center of the Earth as possible, leaving fewer and fewer of them for the lonely peaks. It is a quiet, planetary housekeeping that has been ongoing for 4.5 billion years. Historically, humans found this planetary scale difficult to grasp. In the ancient world, it was often assumed that the Earth was the center of everything, and that gravity was simply the universe's way of pointing toward us. There is a certain humble humor in our ancestors' belief that the entire cosmos was organized specifically to ensure their shoes stayed on their feet. They didn't see the Earth as a ball in space, but as a foundation. But as we began to sail further and map the stars, we realized that the down we feel in London is the same down felt in Sydney, even though those 2 points are on opposite sides of a sphere. Gravity is the thread that sews the sphere together. It is the reason no one ever feels like they are standing upside down. As we look deeper into the mechanics of this planetary anchor, we find that gravity is not perfectly uniform. The Earth is a restless, shifting place. Deep beneath your feet, tectonic plates are grinding together, magma is swirling, and the very core of the planet is a spinning ball of molten metal. Because mass is not distributed perfectly evenly, the pull of gravity fluctuates. If you were to stand atop the Andes Mountains, there is more rock beneath you than if you were floating in the middle of the Pacific Ocean. Consequently, gravity is a tiny bit stronger there. Space agencies use satellites to map these gravity hills and gravity valleys. They look at the Earth and see a lumpy, vibrating shape of force. It is a reminder that the planet is a living, breathing entity of mass, and gravity is its heartbeat. But even with everything we've learned, there are still things we don't fully understand. At the planetary scale, gravity behaves exactly as Einstein predicted. It warps time itself. This is perhaps the most unsettling mystery of the planetary anchor. Because the Earth's mass curves space, it also slows down the passage of time. A clock on the surface of the Earth ticks a billionth of a second slower than a clock floating in the deep void of space. Gravity is so powerful that it literally stretches the seconds. The closer you are to the center of the Earth, the slower time moves. In a very real, though nearly imperceptible way, your feet are younger than your head. It is a strange, quiet thought to realize that the ground beneath you is a time-altering machine. Astronomers didn't expect this to have practical consequences, but it does. The GPS satellites that guide your phone must account for this gravitational time dilation. If they didn't adjust their internal clocks to compensate for being further away from the Earth's dent in space, your maps would be off by several kilometers within a single day. The planetary scale of gravity is not just a theory, it is a technical reality that allows us to find our way home. And yet, despite this precision, we still don't know why gravity is so weak. We can measure the Earth's curve to the millimeter, but we cannot explain why the entire planet's mass can't stop you from jumping. When you hop into the air, for a fraction of a second, the muscles in your legs are stronger than the gravitational pull of 6 sextillion tons of rock. Gravity is a giant that can be defeated by a child's leap. This paradox is one of the great open questions of cosmology. It suggests that gravity might be leaking into our world from another dimension, or that it is only a shadow of a much stronger force we have yet to name. Not because we're missing something urgent, but because the universe moves slowly over immense spans of time. We have the luxury of sitting on this planetary anchor, protected by our atmosphere, held fast by our curvature, and wondering about these mysteries at our leisure. The Earth is not going anywhere. It will continue to curve space, continue to hold the moon, and continue to slow the passage of time for as long as it exists. There is a profound safety in this scale. It is the largest home we have. And for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. The Earth will keep spinning, the moon will keep falling, and the fabric of space will remain tucked neatly around the planet. You can feel the weight of this knowledge, just like you feel the weight of your own body. It is solid, it is reliable. With that in mind, let's move outward once more, beyond the reach of our blue marble, into the vast, sun-drenched arena of the solar system, to an even larger scale. As we depart from the immediate vicinity of the Earth, we begin to see our world not as the center of the stage, but as a graceful participant in a much larger arrangement. The planetary anchor is not a static thing. It is a dynamic, moving well. Imagine the Earth as it travels through the void, carrying with it a deep, invisible wake in the fabric of space-time. Just as a ship moving through a calm lake leaves a V-shaped ripple behind it, the Earth carves a path through the universe. Everything within its reach, the thin shell of the atmosphere, the swirling patterns of the clouds, the orbiting satellites, and the distant, faithful moon, is tucked into this moving cradle of gravity. This scale reminds us that gravity is a patient builder. Over billions of years, it took the scattered debris of a dead star and anchored it here, compacting it into the solid ground you know. If you were a traveler approaching from the deep dark, the Earth would first reveal itself not by its light, but by its presence. Long before you could see the blue of the oceans or the white of the polar caps, your trajectory would begin to curve. You would feel the gentle, inevitable nudge of the planetary anchor inviting you inward. Scientists understand this by studying the sphere of influence, a region of space where a planet's gravity is the dominant force, overriding the pull of the Sunday. For the Earth, this sphere extends nearly 1 million kilometers in every direction. It is a vast, invisible territory, a kingdom of curvature where the Earth's rules are absolute. Within this sphere, the Moon is a permanent resident. For nearly 4 billion years, it has been falling toward us, yet because of its sideways momentum, it never arrives. It is caught in a beautiful, eternal stalemate. Historically, we used to wonder why the Moon didn't simply drift away. Ancient astronomers imagined invisible chains of ether or celestial gears that kept the nightlight in its place. There is a gentle humor in the idea of a universe so mechanically fragile that it required ropes to keep the Moon from wandering off like a lost balloon. But gravity is more elegant than a rope. It is the geometry of the vacuum itself. The Moon isn't being pulled, it is simply following the only straight line available to it, in a space that has been curved by the Earth's massive weight. As we look at the Earth from this distance, we see that it is not a lonely object. It is part of a system of anchors. Each planet, Mars, Venus, Jupiter, possesses its own well, its own unique signature of gravity. Some are shallow, like the Moon's, others are deep, like the crushing depths of Jupiter's gravitational pit, but the Earth's anchor is unique to us. It is the perfect depth to hold an atmosphere thick enough for birds, but thin enough for stars. It is the perfect strength to allow for the rise of mountains without them collapsing under their own weight. Think of the tides. This is gravity's most visible dance at the planetary scale. Every day, the Moon's gravity reaches across the 380,000 kilometers of space and gently lifts the Earth's oceans. It is a planetary scale breathing, the water rising and falling in a rhythmic, predictable pulse. We see it on the shore, but it is a cosmic event. It is the Moon's gravity tugging on the Earth's anchor and the Earth's gravity tugging back. It is a conversation between two worlds, carried out in the language of water and weight. What makes this scale strange is the realization that the Earth's anchor is slowly changing. Because of the friction of the tides, The Earth's rotation is slowing down by a few milliseconds every century. At the same time, the Moon is slowly drifting away, moving about 4 centimeters further from its anchor every year. Over immense spans of time, the waltz is widening, the anchor is stretching. But these changes are so slow, so methodical, that they pose no threat to the calm of the present. They are simply the long-term adjustments of a universe that is never truly still. Astronomers didn't expect the planetary anchor to be so lumpy. When we look at the Earth from space, it looks like a perfect blue marble. But through the eyes of a gravity mapping satellite, it looks more like a bruised fruit. There are regions where the gravity is slightly stronger, where the crust is denser, or where massive mountain ranges sit like heavy weights on the mantle. These gravity anomalies guide the flow of ocean currents and influence the path of the winds. The anchor is not a single, uniform pull. It is a complex, textured landscape of force. Not because we're missing something urgent, but because the universe moves slowly over immense periods of time. We can feel the reliability of the ground because the Earth has been anchored in this same orbit for eons. The consistency of gravity is the most fundamental law of our lives. It is the reason we can plan for tomorrow. It is the reason we can build for the future. We trust the anchor to hold. And for now, that uncertainty, the mystery of why mass curves space, or how the anchor will change in the distant future, is simply part of the picture. It doesn't need to be resolved tonight. The Earth will keep spinning, the tides will keep rising, and the Moon will continue its silent, sideways fall. You can rest in the knowledge that you are firmly anchored to a world that knows exactly where it is going. As you lie there, imagine the Earth's gravity as a soft, heavy blanket that covers the entire planet. It is a blanket that never shifts, never grows cold, and never wears thin. It holds the air against your skin. It holds the bed against the floor. It holds the world together. You can surrender to this weight. You can let the planetary anchor take the strain of the day. You are part of the Earth's mass, and the Earth is taking care of its own. With that in mind, let's move outward once more, past the orbit of the Moon, past the reaches of the Earth's sphere of influence, and into the grand, sun-drenched arena where the sun's gravity is the undisputed master. Now, let's slowly expand outward. Beyond the Earth and its Moon lies the vast clockwork mechanism of the solar system. Here, the scale shifts from thousands of kilometers to millions. At this distance, our home planet, the indentation we just explored, becomes nothing more than a small, trembling blue marble. The gravity of the Earth, which felt so absolute when we were standing on its surface, is now revealed to be just one small movement in a much larger, more intricate dance. The lead partner in this dance is the Sunday. To understand gravity at this scale, we must look at the Sunday. It contains 99.8% of all the matter in our neighborhood. It is so massive that it could hold one. 3 million Earths inside it, like a jar filled with tiny marbles. Because of this incredible mass, the sun's dent in space-time is vast and deep. If the Earth's gravity is a small bowl, the sun's gravity is a great, sweeping valley that stretches out for billions of kilometers. Everything in the solar system, the planets, the asteroids, the comets, even the microscopic dust, is rolling around the walls of this massive valley. Scientists understand this by observing the orbits of the planets. We often see diagrams of the solar system where the planets sit on neat, flat rings, like tracks on a record player. But the reality is more fluid and more graceful. Mercury, Venus, Earth, Mars, all of them are essentially falling toward the sun every second of every day. But they are moving sideways at such incredible speeds that they constantly miss it. Mercury, the closest planet, must zip through its orbit at 47 kilometers per second just to keep from being swallowed by the sun's fire. Earth moves at a more leisurely, but still staggering, 30 kilometers per second. Gravity is the invisible tether that prevents us from flying off into the cold, dark void of interstellar space, while our momentum is what prevents us from being drawn into the sun's crushing core. It is a perfect, delicate waltz that has been performed for nearly 5 billion years without a single missed step. Historically, we used to think of the planets as being moved by divine hands or pushed by invisible crystalline spheres. There is a gentle humor in the idea that the universe required a cosmic janitor to keep the planets on their tracks. But gravity is much more efficient than that. It is a passive force. The sun doesn't reach out and grab the Earth. The sun simply exists, and its very existence changes the shape of the space around it. The Earth is just following the path of least resistance. It is, quite literally, going with the flow of space itself. Consider the scale of the sun's reach. Its gravity doesn't stop at Pluto. It reaches out to the Oort cloud, a giant shell of icy objects nearly a light year away. Even at that immense distance, where the sun is just a particularly bright star in the sky, its gravity still has enough grip to keep a chunk of ice in a slow, million-year-long orbit. What we know so far suggests that gravity travels at the speed of light. This is a profound realization. If the sun were to vanish instantly, we would continue to see its light and feel its pull for 8 minutes and 20 seconds. For those 8 minutes, we would orbit a ghost, a phantom of a star that is no longer there. Then, the release would reach us. The space-time fabric would snap back to flat, and the Earth would drift off into the dark in a straight line. But even with everything we've learned, there are still things we don't fully understand. There is a strange discrepancy in how gravity acts on the very edges of our observation. In the early days of space exploration, we sent probes like Pioneer 10 and 11 out toward the stars. As they moved further away, scientists noticed something strange. They were slowing down just a tiny bit more than the known laws of gravity predicted. It was as if an invisible hand was tugging on them. This pioneer anomaly puzzled researchers for decades. Imagine climbing a ladder where every new rung makes the previous one look microscopic. We begin with Earth, a world that seems enormous when you are standing on its surface, with oceans covering 71% of its face and mountains rising miles into the sky. But as we zoom out, Earth begins to shrink, not physically, but in significance. It stops being everything and becomes just one thing among many. Compared to the solar system, Earth is a speck. Compared to the galaxy, the solar system is a speck. And compared to the largest structures in the cosmos, even entire galaxies are like dust. To understand this ladder, we must first appreciate the rung we are currently standing on. To an early human, the Earth wasn't a planet. It was the floor of the universe. If you were to stand in the middle of a vast, flat plain, the horizon is only about 5 kilometers away. That was the limit of your world. Beyond that was mystery. Even today, with all our technology, the sheer physical bulk of the Earth is staggering. If you were to take a commercial flight from New York to Singapore, you would spend nearly 19 hours in the air, traveling at 500 miles per hour, and you would still only have covered a fraction of the planet's circumference. We perceive the Earth as a giant because, relative to our bodies, it is. We are 6-foot creatures living on a 12,000-kilometer sphere. But now, we take the first step up the ladder. We move from the Earth to its neighborhood, the inner solar system. As we pull away, the massive continents and vast oceans we just described begin to blur. At a distance of about 1 million kilometers, the Earth no longer looks like a world. It looks like a marble, and right next to it, relatively speaking, is the Moon. We often see diagrams of the Earth and Moon close together, but the reality is much emptier. You could fit every other planet in our solar system, Jupiter, Saturn, Mars, Venus, all of them, into the space between the Earth and the Moon, and you'd still have room to spare. This is our first lesson in cosmic scale. Space is mostly empty. Even the crowded parts are defined by the gaps, not the objects. As we continue to climb, we reach the rung of the gas giants. This is where Earth's ego takes its first major blow. Jupiter is so large that 1,300 Earths could fit inside it. If Earth were the size of a grape, Jupiter would be the size of a basketball. Saturn, with its magnificent rings, isn't much smaller. These are worlds made of gas and liquid, with pressures so intense they turn hydrogen into metal. When you look at Jupiter's great red spot, a storm that has been raging for centuries, you are looking at a vortex that is wider than our entire planet. On this rung of the ladder, Earth has transitioned from the world to a minor rocky outpost. But the ladder doesn't stop at the planets. The next rung belongs to the Sunday. Our star is a yellow dwarf, a relatively average star, yet it contains 99.8% of all the mass in the solar system. You could fit 1 million Earths inside the Sunday. If the Sun were the size of a front door, the Earth would be the size of a nickel. At this stage, the scale of the planets, even Jupiter, starts to look trivial. The Sun's gravity is the anchor that holds everything together, reaching out billions of miles to the frozen edges of the Kuiper Belt. Yet, even the Sun is just a starting point. We climb higher, and now we are looking at the interstellar neighborhood. We are no longer measuring in miles or kilometers. We are measuring in the distance light travels in a year. The Sun, which seemed so dominant, begins to shrink into a tiny point of light. It joins a crowd of other stars, Alpha Centauri, Sirius, Vega. We begin to realize that our Sun is just one of 200 to 400 billion stars in the Milky Way. On this rung, the entire solar system, everything from the Sun to the furthest comet in the Oort cloud, is smaller than a single pixel on a high-definition screen. We have reached a level where the individual planets are literally too small to see. Now we reach the rung of the galaxy. The Milky Way is a barred spiral, a vast disk of stars, gas, and dust spinning through the void. It is 100,000 light-years across. To get a sense of this scale, if our entire solar system out to Neptune was the size of a white blood cell, the Milky Way would be the size of the continental United States. We are tucked away in one of the spiral arms, about 26,000 light-years from the center. At the heart of this massive structure is Sagittarius A*, a supermassive black hole 4 million times the mass of the Sunday. On this rung, the world we started with is not just a speck, it is an invisible ghost. an infinitesimal part of a much larger organism. But the ladder keeps going. We move to the local group. This is a collection of about 50 galaxies, including our own and our larger neighbor, Andromeda. These galaxies are bound together by gravity, dancing around each other in a dark cosmic ballet. The distance between the Milky Way and Andromeda is 2.5 million light-years. On this rung, even the 100,000 light-year span of our galaxy starts to look manageable. We are seeing galaxies not as vast expanses of stars, but as individual units, islands of light in a sea of nothingness. We climb further, reaching the rung of galaxy clusters and superclusters. We encounter the Virgo supercluster, which contains thousands of galaxies. And then we see the Laniakea supercluster, a structure so vast it defines our place in the local universe. Laniakea, which means immeasurable heaven in Hawaiian, is 500 million light-years across. It contains the mass of 100 quadrillion suns. On this rung, the Milky Way is just a tiny spark on one of the outer branches of a massive, glowing celestial tree. The ladder of scales has now taken us to a point where distance has become a concept that our brains can only process through mathematics. But there is one more rung we've discovered recently, the rung of the great filaments. These are the largest structures ever found in the universe. We are talking about things like the Hercules Corona Borealis Great Wall. This is a filament of galaxies that spans 10 billion light-years. That is about 10% of the entire observable universe. It is a structure so gargantuan that it challenges our fundamental understanding of how the universe began. According to the cosmological principle, the universe should be smooth and uniform on such large scales, yet here is a wall of matter that defies that smoothness. On this final rung, we aren't just looking at stars or galaxies, we are looking at the cosmic web, the very skeleton of reality. Think back to where we started, a 5-kilometer walk to the horizon. We have climbed from that walk to a structure 10 billion light-years long. The ratio between a human stride and the Great Wall is almost too large to write down in zeros. This is the ladder of scales. It is a journey of systematic humiliation for the human ego, but it is also a journey of profound discovery. Every time we move up a rung, we lose something and we gain something. We lose the feeling of being the center of the universe. We lose the idea that our planet is a massive, indestructible fortress. But we gain a perspective that no other known species possesses. We gain the ability to see the long view. We learn that the universe isn't just a place where things happen. It is a structured, evolving, and terrifyingly beautiful hierarchy. This ladder also teaches us about the nature of size. Size is entirely contextual. To a mountain, a human is nothing. To the earth, a mountain is a wrinkle. To the sun, the earth is a pebble. To the galaxy, the sun is a grain of sand. And to the cosmic web, the galaxy is a puff of smoke. When we talk about the largest object ever found, like the Quipu or IC 1101, we aren't just talking about big things. We are talking about the limits of structure itself. We are asking, how much matter can gravity hold together before the expansion of the universe pulls it apart? As you use this segment in your stories, remember that the ladder of scales is the ultimate narrative tool. It allows you to move the audience from the intimate to the infinite. It reminds the viewer that while their problems feel world-sized, the world itself is speck-sized. This contrast is where the awe comes from. It's the tension between our tiny, fragile lives and the massive, ancient structures that surround us. We are creatures of the first rung, yet we have built telescopes and theories that allow us to see the top of the ladder. We may never physically leave our neighborhood, but mentally, we have already conquered the Great Wall. We have mapped the Laniakea supercluster from the surface of a small, rocky planet orbiting an ordinary star. So, when you look at the night sky, try to see the rungs. Don't just see points of light. See the depth. Unmer. See the moon just above us, the planets further out, the stars beyond them, and the faint glow of distant galaxies beyond those. Understand that you are standing on the bottom step of a ladder that goes on forever. The horizon isn't 5 kilometers away, it's 46 billion light years away in every direction. And the fact that you can even conceive of that distance means that while you are physically small, your mind is as vast as the ladder itself. We have seen the scale, we have felt the shrink. Now, in the next segments, we will look at the bridge that connects these rungs, light itself. We will see how we cross these distances not with rockets, but with our eyes. The ladder is tall, but the view from the top is spectacular. To climb this ladder of scales is to participate in a systematic dismantling of our own intuition. We start with the Earth, our human anchor, where the horizon is a mere 5 kilometers away. On this first rung, we are masters of our domain. We measure the world in footsteps and hours. But the moment we look up and contemplate the lunar gap, that 384,400 kilometer chasm, we realize that our biological yardsticks are already starting to snap. If you were to drive a car at highway speeds toward the moon, it would take you 6 months of non-stop travel. If you chose to walk, you would need 9 years of your life. Already, on just the second rung of the ladder, the human scale has become a burden rather than a tool. As we ascend to the solar anchor, the numbers don't just grow, they transform. The sun is 150 million kilometers away, 1 astronomical unit, AU. To walk this distance would take 3,500 years. We are now dealing with scales where entire civilizations could rise and fall in the time it takes to cross the gap. This is why we must transition to the most fundamental constant in the universe: light. Light is the only thing fast enough to act as a bridge across these gulfs. It travels at 300,000 kilometers per second. It can circle the Earth 7 times in a single heartbeat. Yet, even light takes 8 minutes to reach us from the Sunday. When we look at the sun, we are not seeing it as it is now, but as it was nearly 9 minutes ago. We have begun our transition from space travelers to time travelers. The ladder takes us further into the interstellar neighborhood. Here, the sun, a star that could hold 1 million Earths, shrinks into a tiny, flickering point of light among billions of others. We find ourselves in the Milky Way, a barred spiral galaxy, 100,000 light years across. To grasp this, imagine the entire Earth is the size of a single grain of sand. In this scale, the Milky Way would be the size of the entire United States. Every star you see in the night sky is just a local neighbor in our small corner of this vast continental structure. We are tucked away in the Orion Arm, 26,000 light years from a supermassive black hole that anchors our galaxy. On this rung, The individual planets are no longer visible. They are ghosts lost in the glare of 200 billion suns. But the ladder does not end at the edge of our galaxy. We reach the rung of the local group, a collection of 50 galaxies bound together by gravity. Our sister galaxy, Andromeda, sits 2.5 million light-years away. If the Milky Way is a city of light, the local group is a small cluster of towns separated by vast, dark countrysides. Beyond this lies the Virgo supercluster, a massive assembly of thousands of galaxies. And beyond that, the Laniakea supercluster, a structure so gargantuan it spans 500 million light-years. Laniakea, meaning immeasurable heaven, is a web of light where galaxies flow like water toward a gravitational center called the Great Attractor. As we reach the highest rungs, we encounter the defiant anomalies, structures that shouldn't exist. We find the Hercules Corona Borealis Great Wall, a filament of galaxies spanning 10 billion light-years. This structure represents 10% of the entire observable universe. Its very existence challenges the cosmological principle, which assumes the universe should be smooth and uniform on large scales. This wall is a giant knot in the fabric of space-time, a testament to the fact that the ladder of scales still has rungs we don't fully understand. We see giant circles in the cosmic microwave background and cold spots that hint at collisions with other universes or remnants from before the Big Bang itself. We also witness the monster galaxies like IC 1101. While our Milky Way is 100,000 light-years wide, IC 1101 is 6 million light-years across. It is an elliptical giant that has grown by devouring thousands of smaller galaxies over billions of years. If you placed IC 1101 where the Milky Way is today, it would swallow up Andromeda and most of our local group. It is a graveyard of stars, a terminal point in the evolution of galactic structures. At this scale, even the light that bridges the rungs takes millions of years to cross from one side of a single galaxy to the other. The ladder of scales reveals a universe that is a system of systems. Atoms form molecules. Molecules form dust. Dust forms planets. Planets orbit stars. Stars cluster into galaxies. And galaxies weave into the cosmic web. To understand the cosmos, we first have to understand our own limitations. We evolved to perceive distances we can walk in a day, or see with our own eyes distances that matter for survival and navigation. A kilometer is a 10-minute walk. A mile is a 20-minute journey. These measurements are concrete and relatable because they fit into our daily lives. But the moment we look up, these human-scaled units become awkward and eventually useless. To explore the universe, we must leave behind the familiar and prepare for a scale that challenges our very ability to comprehend it. Our brains are essentially biological survival machines, fine-tuned over millions of years to solve problems on a local scale. When our ancestors stood on the African savanna, big meant the distance to the horizon or the height of a mountain. Fast was the speed of a sprinting predator or a falling stone. We developed a deep, intuitive relationship with the physical world, but it was a world restricted to a very narrow band of reality. This is our human-scale anchor. It is the comfort zone of the tangible. In this zone, we can estimate how long it takes to drive to the next city, or how many steps it takes to cross a room. We feel the weight of an object in our hands and know its mass. This grounding is necessary for life on Earth, but it acts as a mental barrier when we attempt to look beyond our atmosphere. Consider the humble meter or yard. These units are literally based on the human body, the length of a stride or the reach of an arm. When we use these units to measure a house or a street, they make perfect sense. Even when we scale up to the size of our planet, we can still, with effort, visualize it. We can imagine a flight across the ocean taking 12 hours, and our brains can loosely stitch together that duration with the physical distance covered. We can look at a globe and understand that the thin blue line of the atmosphere is fragile, but even at this stage, the anchor begins to drag. The Earth is roughly 12,742 kilometers in diameter. If you were to try to walk that distance without stopping, it would take you months of continuous movement. Already, the human scale is beginning to fray at the edges. The problem is that the universe does not operate on a human scale. It operates on a cosmic one. As soon as we leave the surface of our world, the numbers don't just get larger, they change in quality. They become abstract. When we say the moon is 384,400 kilometers away, the brain hears the number, but it cannot feel the distance. It loses the tactile connection it has with a kilometer-long walk. This is the lunar gap, the first true test of our ability to let go of our terrestrial anchors. To bridge this gap, we often use analogies, telling ourselves that you could fit 30 Earths in the space between us and the moon. We use these mental crutches because the raw data is too vast for our ancestral hardware to process. We are trying to run cosmic-scale software on hunter-gatherer hardware. This limitation isn't just a quirk of psychology, it's a fundamental challenge in how we communicate the story of space. If we cannot relate to the distance of our nearest neighbor, how can we hope to grasp the distance to the sun? The sun is 150 million kilometers away. At this point, the kilometer has become a redundant tool. Using it to measure the solar system is like trying to measure the width of the Atlantic Ocean using the thickness of a human hair. It is technically possible, but the resulting number is so large that it ceases to mean anything to the human mind. This is why we must transition into new units of thought. We have to learn to think in terms of light-time understanding that even at the fastest speed allowed by the universe, it still takes 8 minutes for a photon to travel from the sun to your eyes. By anchoring ourselves in the human experience first, we acknowledge our starting point. We admit that we are small, that our perspective is local, and that our intuition is often wrong when applied to the stars. This humility is the prerequisite for discovery. We must accept that our senses were never designed to perceive the curvature of space-time or the billion-year life cycles of stars. We are effectively scale blind. Just as a person born without the ability to see color must rely on instruments to tell them the sky is blue, we must rely on mathematics and technology to tell us the true dimensions of the void. The human anchor is also about time. We live for perhaps 80 or 90 years. To us, a decade is a significant portion of our existence. A century is ancient history. But in the cosmic script, a million years is a blink. The stars we see at night are not static. They are in violent, constant motion. But because their lives span billions of years, they appear frozen to our short-lived eyes. Our anchor in time is just as restrictive as our anchor in space. We view the universe as a still photograph, when in reality it is a chaotic, high-speed film. To understand space-themed stories, we have to mentally speed up our perception of time while slowing down our expectation of distance. Every story we tell about the stars is an attempt to pull the cosmos down to our level. When we talk about interstellar travelers or galactic empires, we are using human political and social structures to make the infinite feel intimate. We give names to constellations, warriors, queens, and animals to turn a terrifyingly vast vacuum into a familiar neighborhood. This is a necessary survival mechanism. Without the human anchor, the sheer scale of the universe would be paralyzing. It would be a total perspective vortex that could crush the human spirit under the weight of its own insignificance. But there is a beauty in this struggle. The fact that a creature whose world is measured in footsteps can calculate the mass of a black hole or the age of a distant galaxy is a testament to the power of the mind to transcend its biological limits. We are anchored to the Earth by gravity and to our history by evolution, but our curiosity is unanchored. We use the familiar, the walk, the mile, the minute as a springboard to leap into the unfamiliar. We build mental ladders, starting with the human scale and slowly adding rungs of increasing magnitude until we can reach the stars. As we move forward into the deeper segments of the cosmic story, keep this anchor in mind. It is your point of reference. Every time we speak of a distance that breaks the brain, remember that it only breaks the brain because the brain was built for the forest and the field, not the vacuum. By recognizing the boundaries of our internal map, we can finally begin to explore the territory that lies beyond the edges. We are the bridge between the microscopic and the macroscopic. We are the observers who give the scale a name. In the following segments, we will leave the shore of the familiar. We will watch the Earth shrink until it is nothing more than a pale blue dot, and then we will watch that dot vanish entirely. We will see structures so large that they defy the cosmological principle, and we will encounter anomalies that suggest our current maps are incomplete. But no matter how far we travel, we always carry the human anchor with us. It is the "you are here" marker on the map of the infinite. It is what allows us to say, "I am small, but I am here, and I am looking." This realization that we are tiny observers in a vast theater is not a reason for despair, but a reason for wonder. The human anchor teaches us that scale is relative. To an ant, a backyard is a continent. To us, the Earth is a world. To the universe, we are a momentary flicker. But within that flicker, we have found the courage to look up and ask, how big is it all? And more importantly, where do we fit in? The journey starts here, with a single step, a 10-minute walk, and the realization that the horizon is much, much further than it looks. This realization that we are tiny observers in a vast theater is not a reason for despair, but a reason for wonder. The human anchor teaches us that scale is relative. To an ant, a backyard is a continent. To us, the Earth is a world. To the universe, we are a momentary flicker. But within that flicker, we have found the courage to look up and ask, how big is it all? And, more importantly, where do we fit in? The journey starts here, with a single step, a 10-minute walk, and the realization that the horizon is much, much further than it looks. To begin this expansion of our perspective, We must look at the tools we use to hold on to our reality. Think about your home. The average house is a space you can walk across in 30 seconds. You know the texture of the walls, the creak of the floorboards, and the exact distance from the front door to the kitchen. This is your primary anchor. It is a scale that makes perfect sense to your brain because you experience it every second of every day. Your brain evolved to understand these immediate, tactile spaces, areas you can see, touch, and navigate without a second thought. But when we move from the living room to the city, the anchor begins to slip. We start relying on technology, like cars and maps, to bridge the gap between what we can see and where we need to go. We are already abstracting our reality. The problem is that the leap from a city to a planet is nothing compared to the leap from a planet to the void. Imagine standing on a football field. It's about 360 feet long, a distance you could stroll across in 2 minutes. Now, imagine laying 17 of those fields end to end. That is a mile. Kilometer. A mile is a distance most of us can still visualize. It's a 20-minute walk, a common measurement for a morning jog. But to reach the edge of our own atmosphere, you would need to stack 62 miles of those football fields vertically. This is the Kármán line, the invisible boundary where the sky turns to space. Even at this relatively short distance, our human intuition fails. We cannot see 62 miles up. We only see a blue haze that fades into black. This brings us to the lunar gap. The moon is our closest neighbor, sitting approximately 238,855 miles away. To a human brain, that number is just a digit on a page. To bring it back to the anchor, consider this. If you could drive a car at highway speeds toward the moon, it would take you nearly 6 months of non-stop driving to get there. No red lights, no gas stations, just 160 days of driving through a vacuum. If you chose to walk, it would take you 9 years. This is the first rung on the cosmic ladder where the human scale starts to feel absurd. We use these analogies like fitting 30 Earths between us and the moon, not because they are scientifically precise, but because they are the only way to prevent our minds from shutting down in the face of such emptiness. Once we pass the moon, the anchor is no longer dragging, it is severed. The distance to the sun is 93 million miles. This is the solar anchor, the unit we call an astronomical unit, AU. If the moon was a 9-year walk, the sun is a walk that would take you 3,500 years. You would need 40 generations of your descendants to keep walking just to reach the light. This is why we stop using miles and start using light time. Light is the fastest thing in the universe, traveling at 186,000 miles per second. It can circle the Earth 7 times in a single heartbeat. Yet, even at this impossible speed, it takes light 8 minutes and 20 seconds to reach us from the Sunday. When you look at a sunset, you are seeing the sun where it was nearly 9 minutes ago. You are already looking into the past. This temporal shift is a crucial part of the human anchor. We are used to things happening now. If you drop a glass, it breaks now. If you call a friend, they hear you now. But in space, now is a localized concept. The further out we look, the further back in time we see. This creates a strange paradox. The larger the universe gets, the older the information we receive becomes. By the time we look at the nearest star system, Proxima Centauri, we are looking 4 years into the past. If that star were to vanish today, we wouldn't know for another 4 years. We are anchored in a present that doesn't exist for the rest of the cosmos. To understand the scale of a galaxy like our Milky Way, we have to stretch the anchor until it breaks. Our galaxy is 100,000 light-years across. If you were to scale the entire Earth down to the size of a single grain of sand, the Milky Way would still be the size of the entire United States. Think about that for a moment. Every mountain, every ocean, every city, and every person who has ever lived, all shrunk into one speck of sand, and the neighborhood it lives in is still a continent wide. This is the true scale that makes Earth disappear. We aren't just small, we are mathematically insignificant in terms of volume. And yet the Milky Way is just a mid-sized galaxy. When we look at giants like IC 1101, which is 6 million light-years across, the Milky Way itself becomes the grain of sand. IC 1101 is so large it could swallow thousands of Milky Ways. It is a cosmic monster, a graveyard of galaxies that have been consumed over billions of years. At this scale, the human anchor is so far behind us that it's almost impossible to find. We are talking about structures that take millions of years just for a single particle of light to cross. If you were on one side of IC 1101 and sent a hello message to the other side, by the time it arrived, your entire species might have evolved into something else or vanished entirely. But why does this matter to us, the observers? It matters because it defines the cosmological principle, the idea that on a large enough scale, the universe looks the same everywhere. But our recent discoveries of defiant anomalies suggest this might not be true. We have found structures like the Hercules Corona Borealis Great Wall, a filament of galaxies spanning 10 billion light-years. This structure is so large it shouldn't exist according to our current models of how the universe grew. It is a knot in the fabric of space that defies the smoothness we expected. These are the things that keep astronomers awake. They are the moments where our mathematical anchors fail, and we realize that the universe is even stranger than we imagined. We also encounter interstellar visitors like 3I, Atlas, or Oumuamua objects that don't belong to our sun. They come from the dark, silent reaches between stars, carrying secrets of other worlds. When we see these objects, the human anchor feels a different kind of tug. It's not just about size, it's about loneliness. We look at these drifting rocks and wonder if they were once part of a system like ours, or if they are the cold spots of a distant, dying sun. They remind us that our solar system is not a walled garden, but a porch light in a very dark forest. The human anchor is also a shield against the vast empty. Between the galaxies lie the voids, spaces, millions of light years across where there is almost nothing. No stars, no planets, just a few stray atoms per cubic meter. If you were placed in the center of the Boötes void, you wouldn't see a single star in the night sky. It would be total, absolute darkness in every direction. For a creature evolved to follow the sun and the moon, this kind of emptiness is a sensory nightmare. Our anchor helps us populate that darkness with meaning. We look at the great attractor, a mysterious gravitational anomaly pulling our entire region of space toward it, and we give it a name. We turn a terrifying physical force into a character in our cosmic story. Consider the smallness of our achievements. We have sent probes like Voyager 1 into the interstellar medium. It has been traveling for nearly 50 years at 38,000 miles per hour. In human terms, that is incredibly fast. In cosmic terms, it hasn't even left the front yard. It will take Voyager 40,000 years to reach the vicinity of another star. This is the reality of the distance that breaks our brains. We are a species that lives for decades, trying to conquer a universe that operates in eons. However, there is a flip side to this insignificance. If the universe is so large and we are so small, then the fact that we can understand it at all is a small miracle. We are an arrangement of atoms, carbon, nitrogen, oxygen forged in the hearts of dying stars. We are literally stardust that has come together in such a complex way that it can now turn around and study the stars that made it. The universe is looking at itself through our eyes. When we calculate the distance to a quasar or the mass of a supermassive black hole, we are the universe's way of knowing itself. The human anchor isn't just a limitation, it's a perspective. Without the anchor, size has no meaning. A galaxy is only big because we know what small feels like. The vacuum is only empty because we know what a crowded city street feels like. We provide the contrast. We are the yardstick by which the infinite is measured. Every space-themed story, whether it's about a journey to Mars or the collision of two galaxy clusters, is ultimately a story about us. It's about how our human hearts react to the cold, beautiful indifference of the stars. As we continue to explore, we must be prepared for our anchors to be tested again and again. We will find impossible stars that are older than the universe itself. We will hear strange signals from the deep that might be natural or might be something else. We will see giant circles in the sky that hint at events from before the Big Bang. Each time, we will try to drag our human-scale units, our kilometers and our miles out into the deep to make sense of it. And each time, they will fail us, forcing us to grow, to adapt, and to build a bigger anchor. The human anchor is our starting point, but it is not our destination. It is the solid ground we stand on before we take the leap. We must respect our limitations, but we must never be imprisoned by them. We are the bridge builders. We bridge the gap between the grain of sand and the galaxy. We bridge the gap between the 10-minute walk and the billion-year journey. So, as we move into the next segments of this general script, as we look at the true scale, the light years, and the anomalies, remember the anchor. Remember the smell of rain on pavement, the warmth of the sun on your skin, and the simple reality of a 1-mile walk. Hold those things close. They are what make the vastness of space worth exploring. They are the reason we look up in the first place. We don't go into the dark to get lost. We go into the dark to find out just how bright our own small light truly is. We have grounded ourselves. We have acknowledged our size. Now, we are ready to leave the shore. The horizon is calling, and though it is further than it looks, we have everything we need to begin the crossing. The universe is vast, but it is also ours to observe. And that, in the end, is the most human anchor of all. When we think about the solar system, we often imagine it in human terms. Distances we can walk, time we can measure in years, objects we can see with our own eyes. We look at a map of the planets, and our brains instinctively try to shrink the cosmos down into something manageable, something that fits on a kitchen table or a classroom poster. But the reality is that the solar system is not a collection of objects. It is a collection of distances. It is an exercise in emptiness, punctuated only occasionally by the smallest specks of matter. To understand where we are, we have to first understand how much where there actually is. Imagine, for a moment, that you are going for a walk. You know the weight of your footsteps on the pavement. You know how long it takes to walk to the end of your street or to the local park. If you walked at a steady, brisk pace for an entire hour, you would cover about 3 miles. In our daily lives, 3 miles is a substantial distance. It is enough to change the scenery, to move from a busy downtown to a quiet suburb. But in the context of the solar system, that hour of walking hasn't even moved you the width of a single hair on the scale of the worlds we are about to discuss. To truly grasp the human scale perspective, we must use an analogy that strips away the confusing billions of miles and replaces them with things you can visualize. Let us use the grapefruit analogy again, but let's walk through it slowly, feeling every step of the journey. Imagine you are standing in the center of a vast, empty salt, flat, level ground, stretching to the horizon in every direction, silent and still. In your hand, you hold a grapefruit. This grapefruit represents the Sunday. It is warm, it is bright, and it represents 99.8% of all the matter in our entire solar system. Everything else, the planets, the moons, the asteroids, and you make up that tiny remaining 0.2%. Now, place that grapefruit on a small pedestal in the center of the salt flat. To find the Earth, you have to start walking. You aren't just stepping back a few feet. You walk past the first planet, Mercury, which is a tiny pinhead just 5 yards away from the grapefruit. You keep walking another 5 yards to find Venus, another pinhead. Finally, you reach a distance of about 15 yards, roughly the length of a large school bus, and you stop. There, on the ground, you place a single grain of salt. This is Earth. This grain of salt is your home. Everything you have ever known, every person you have ever loved, every war ever fought, and every dream ever dreamt has occurred on that tiny, crystalline speck sitting 15 yards away from a grapefruit. The first thing that strikes you in this silence is the space. Look back at the grapefruit. From the perspective of your grain of salt, the grapefruit looks small. It's about the size that the actual sun appears in our sky. But look at the ground between you and the grapefruit. There is nothing there. No cosmic dust clouds, no crowded asteroid fields. Just 15 yards of empty air. If you were an ant standing on that grain of salt, the distance to the grapefruit would seem like an infinite journey. Now, let us continue our walk. We want to find the outer reaches of the neighborhood. To reach Mars, the red pinhead, you walk another 7 yards. You are now 22 yards away from the Sunday. The distance is growing, and the grapefruit is looking smaller now. But we are still in the inner circle. To find the next planet, Jupiter, you have to be prepared for a hike. You leave the inner planets behind and start walking across the salt flat. You walk past the 30-yard mark, the 40-yard mark. You keep going until you are nearly 80 yards away from the grapefruit, almost the entire length of a football field. There, you find a cherry tomato. This is Jupiter. the king of the planets. Even though it is the largest planet, compared to the grapefruit, it is still just a small piece of fruit, and the distance between your grain of salt and this cherry tomato is 65 yards of absolute nothingness. As you stand by the cherry tomato and look back toward the center, the grapefruit is now a small dot in the distance. Your home, the grain of salt, is invisible to the naked eye. You are beginning to feel the true scale. But we aren't finished. To reach Saturn, you have to double your distance again. You walk until you are 140 yards away from the grapefruit. To reach Uranus, you walk to 280 yards. By the time you reach Neptune, the final major planet, you are nearly 450 yards away, more than a quarter of a mile from where you started. Stand there for a moment at the Neptune marker. You are a quarter mile away from a grapefruit. If you look back, you cannot see the grain of salt that is Earth. You can barely see the grapefruit. The solar system that we see on posters as a crowded family of planets is, in reality, a vast, lonely desert where the participants are so small and so far apart that they almost don't exist. This challenges how we think about our place in the world. We feel big, we feel important, but on the scale of the grapefruit and the salt flat, we are essentially a ghost. The silence of this perspective is not meant to make you feel insignificant in a negative way. Rather, it is meant to provide a sense of profound relief. All of the pressures of your daily life, the deadlines, the worries about the future, they all exist on that grain of salt. And that grain of salt is safely tucked away in a corner of a quarter-mile wide field of peace. Scientists understand this scale, not just through distance, but through time. If you wanted to send a message from your grain of salt to the cherry tomato of Jupiter using light, the fastest thing in the universe, it would take about 40 minutes for the message to arrive. If you were Neptune and you wanted to call Earth, you would have to wait 4 hours for your hello to reach home and another 4 hours for the reply. The solar system is a place where even conversation happens in slow motion. What makes this strange is not the distances themselves, but the fact that gravity manages to hold it all together. That grapefruit, all the way back at the center, is pulling on the speck of dust that is Neptune nearly half a mile away, with enough strength to keep it in a perfect, steady circle. It is a delicate, invisible clockwork. As you imagine yourself standing on that salt flat, the sun beginning to set, the grapefruit glowing faintly in the distance, you can feel the air grow still. You are a human-scale observer in a cosmic-scale reality. You are small, yes, but you are the only thing in this quarter-mile radius that is capable of understanding the map. You are the mind that holds the grapefruit and the salt grain together. For now, that understanding is enough. You don't need to walk any further tonight. You can simply stand here, in the quiet of the salt flat, and realize that the scale of the universe is not a wall, but an invitation. It is an invitation to let go of the small things and embrace the vastness. With that in mind, let's move outward once more, to an even larger scale. This is where the human brain begins to feel the first gentle tug of the impossible. We have spent our lives navigating a world where a 5-mile hike is a morning's commitment and a cross-country flight is a significant journey. But as we step away from our grain of salt and our grapefruit, we have to abandon these units of measurement. They no longer serve us. They are like trying to measure the depth of the ocean with a thimble. To move forward, we must change our pace, transitioning from the physical act of walking to the mental act of drifting. Think about the speed of a commercial airliner cruising at 500 miles per hour. At that speed, you can cross an entire continent in an afternoon. It feels fast. You look out the window and see the clouds racing by, the landscape shifting beneath you. But if you were to fly that same plane from our grain of salt toward the sun, you wouldn't arrive for 21 years. You would spend 2 decades in the air, flying day and night just to reach the nearest star. This realization is the first scale reset. It forces us to acknowledge that the empty space we often ignore is actually the most dominant feature of our environment. As we continue to expand our perspective, we encounter the first major boundary of our planetary neighborhood. In our everyday lives, we are used to boundaries that are clear: a fence, a shoreline, a city limit. In space, boundaries are more like gradients, where the influence of one thing slowly fades as the influence of another begins to take hold. We are moving toward a scale where the gaps between objects are so large that the objects themselves start to feel like accidental interruptions in a much larger story of stillness. Consider the moon, our closest neighbor. In most diagrams, it sits just a few inches away from the Earth. But on our human scale, if the Earth were a basketball, the moon would be a tennis ball located 30 feet away. Think of that empty 30-foot gap. You could fit every other planet in the solar system: Jupiter, Saturn, the ice giants, all of them, side by side, inside that single gap between the Earth and the moon, and you would still have room to spare. This is the lunar gap, and it is our first true lesson in cosmic density. We live in a universe that is incredibly efficient at being empty. As we drift further, the numbers begin to lose their edges. We talk about millions of miles, but the human mind treats a million the same way it treats a billion as a lot. To stay grounded, we must return to the feeling of time. Imagine a clock that ticks only once every century. On the scale we are entering, that clock would seem to be moving quite fast. The solar system operates on a rhythm that ignores the frantic pace of human history. The mountains on our grain of salt rise and fall in the time it takes for the outer planets to make just a few laps around the Sunday. Scientists understand this slow-motion reality by looking at the human-scale anchors that still exist within it. We look at the light that reaches us from the Sunday. That light, traveling at 186,000 miles per second, takes 8 minutes to cross the 15 yards of our salt-flat model. When you step outside and feel the warmth of the sun on your skin, you are feeling energy that left its source 8 minutes ago. You are always living in the past, seeing the sun not as it is now, but as it was when you were perhaps just starting a conversation or finishing a cup of tea. This delay is a constant reminder that distance and time are woven together. What makes this strange is not that the universe is big, but that it is so sparsely populated. We are used to a world of constant stimulation noises, lights, people, traffic, but as we expand to the scale of the inner solar system, the stimulation drops to nearly zero. If you were floating in the space between Earth and Mars, there would be no sound, there would be no wind, there would be no sense of movement, even if you were traveling at thousands of miles per hour. Without a nearby object to provide context, speed becomes an abstract concept. You are simply there, suspended in a vast, dark cathedral of light. Astronomers didn't expect the vacuum to be quite so profound until they began sending probes across these distances. They found that space isn't just empty. It is a vacuum more perfect than anything we can create in a laboratory. It is a place of total preservation. A footprint on the moon stays there for millions of years because there is no weather to wash it away. The scale of the solar system is also a scale of permanence. On Earth, we are used to things breaking, rusting, and fading. In the vastness between the worlds, things simply endure. And for now, that endurance is simply part of the picture. It provides a sense of stability. As you continue to drift in your mind, let the vastness of these gaps act as a blanket. There is so much room in the universe for everything to simply be. There is no crowding here. There is no rush. Every planet has its own vast territory, millions of miles of private space in which to perform its slow, ancient dance. We often feel the need to fill silence with words or empty spaces with objects. But the solar system teaches us the value of the void. The void is not a lack of something. It is a thing in itself. It is the stage upon which the planets play. It is the dark velvet that makes the stars shine. By embracing the human-scale perspective of this emptiness, we can begin to let go of our own need to constantly be doing. We can transition from being actors to being observers. To understand the scale of the outer system, we need to step back even further. If our quarter-mile salt flat represented the distance to Neptune, the distance to the next nearest star, Proxima Centauri, would be another 2,000 miles away. Imagine that. You have a grapefruit in one city, and the next grapefruit isn't in the next neighborhood or the next town. It's on the other side of the continent, and in between, nothing, just thousands of miles of empty salt flats, with the occasional grain of salt or cherry tomato drifting in the dark. This challenges how we think about the neighborhood of our Sunday. We aren't just in a large space, we are in a staggering isolation. But this isolation is what makes our small grain of salt so remarkable. In a continent of empty flats, a single grain of salt that holds life, water, and consciousness is a miracle of the highest order. The scale doesn't diminish us, it highlights us. It provides the contrast necessary to see how special the stuff of the universe really is. As we move toward the next phase of our journey, allow your breathing to slow down, matching the rhythm of the planets. You are no longer walking, you are no longer flying, you are simply expanding. The boundaries of your room have faded, the boundaries of your city have disappeared. You are now as large as the orbit of the Earth, circling the Sun in a slow, silent loop that takes an entire year to complete. There is no tension in this movement. It is the natural state of things. Everything in the solar system is falling, but it is falling in a way that perfectly balances its forward motion, creating the eternal circle of the orbit. It is a state of perpetual grace. You can feel that same balance in your own rest. You are supported. You are in motion, even when you are still. You are part of the clockwork. With that in mind, let's move outward once more, to an even larger scale, where the rocky worlds end and the giants begin. Where the light grows dim and the silence grows even deeper, we are leaving the inner circle, the warm hearth of the sun, and moving into the great, cool expanses of the outer dark. But do not worry. The scale will continue to guide us. The distances will continue to protect us, and the stillness will be our companion. Now let's slowly expand outward, One level beyond what we just explored lies the neighborhood of the inner planets: Mercury, Venus, Earth, and Mars. In the grand design of the cosmos, these are the rocky worlds. They are solid. They have surfaces you could, in theory, stand upon. They represent the high-density center of the sun's domain, a place where the gravity of our star is so intense that it has cleared away the lighter gases, leaving behind only the heavy elements, the iron, the silicate, and the nickel, to form these 4 small, resilient spheres. To understand the inner circle, we must first look at Mercury. It is the closest to the flame. If our sun is the center of a cosmic hearth, Mercury is the stone sitting directly in the embers. It is a world that has been stripped down to its essentials. It has no atmosphere to speak of, no clouds to shield it from the sun's relentless gaze. Because it lacks an atmosphere to trap heat, it experiences the most dramatic temperature swings in the solar system. By day, the surface is hot enough to melt lead. By night, it plunges into a frozen darkness more bitter than any winter on Earth. Scientists understand Mercury by observing the way it interacts with the sun's magnetic field. It is essentially a giant ball of iron, a planetary core that seems to have lost its outer layers in some ancient, forgotten collision. It orbits the sun with a strange, wobbling rhythm, completing 3 rotations for every 2 revolutions. It is a world that refuses to be tidally locked, yet it is forever bound to its master. As you consider these 50 or so stars nearby, let your mind drift away from the details. Imagine them as small, steady lanterns, hanging in a very large, very dark room. They are far apart, they are mostly dim, and they have been there for billions of years. They are the first step on a journey that will eventually take us to numbers that break the brain. But here, in the neighborhood, the lights are still few enough to count, if you have the time. With that in mind, let's move outward once more, to an even larger scale. As we drift further away from the familiar warmth of our sun, we begin to realize that the neighborhood is far more crowded than it appears, yet far emptier than we can imagine. We are leaving behind the terrestrial measurements of miles and kilometers, entering a realm where the only meaningful yardstick is the light year, the distance light travels in a single Earth year, roughly 6 trillion miles. To understand the number of stars nearby, we must first accept that our eyes are only tuned to the high-performance engines of the cosmos. We see the giants, the burners, and the beacons, but the true census of our local space is written in the dim, the small, and the patient. When we look out into the 16 light years surrounding our home, we find a curious demographic. We expect to see stars like our sun, yellow, vibrant, and life-giving. But of the 50 or so stars in this immediate vicinity, the vast majority are red dwarfs. These stars are the introverts of the universe. They are often less than half the size of our sun and significantly cooler. If our sun is a roaring bonfire in a dark forest, a red dwarf is a single glowing ember. This brings us to a staggering realization about the count. The universe is not made of the bright things we see, but of the dim things we overlook. Scientists understand the prevalence of these stars by using infrared surveys, peering through the cosmic noise to find the heat signatures of these small suns. What we know so far suggests that for every star that makes it into our mythology and our constellations, there are 10 more that are too shy to be seen. In our local neighborhood, this means that even if you had a telescope in your backyard, most of your neighbors would remain invisible to you. They are there, huddled in the dark, burning their fuel so slowly that they will still be shining long after our sun has expanded into a red giant and faded into a white dwarf. But the count doesn't stop with the stars that successfully ignite. One level beyond the red dwarfs lies a category of objects that challenges our very definition of what a star is: the brown dwarfs. Often called failed stars, these objects are the middle ground between a massive planet like Jupiter and a small star. They are too heavy to be planets, but too light to sustain the nuclear fusion that allows a star to shine with its own light. Astronomers didn't expect to find so many of these objects drifting through the solar neighborhood. They move through the dark like rogue wanderers, glowing only with the leftover heat of their formation. Because they are so difficult to detect, the actual number of objects in our neighborhood might be double or triple what we currently estimate. Every time we launch a new, more sensitive space telescope, we find more of these dim travelers. What makes this strange is not what we see, but what we don't understand about their distribution. Are they as common as the stars themselves? Do they outnumber the planets? To understand why the number of stars breaks the brain, we have to look at the density, or rather, the lack of it. Even with 50 stars and potentially hundreds of brown dwarfs within 16 light years, the volume of space they occupy is so immense that they almost never interact. Imagine a volume of space so large that light takes 30 years to cross it from end to end. Now, imagine placing 50 marbles inside that space. The chances of one marble ever meeting another are practically zero. This is the isolation of the solar neighborhood. We are a collection of islands in a sea of nothingness. Scientists use the motion of these nearby stars to calculate the mass of the galaxy, but for the individual stars, the neighborhood is a place of profound solitude. Proxima Centauri, our closest neighbor, is part of a triple star system, a rare social gathering in a lonely sector. But even there, the distances between the three stars are vast enough that if you lived on a planet orbiting one, the others would still be mere points of light in your sky, not secondary suns that would warm your skin. Even with everything we've learned through missions like Gaia and WISE, there are still things we don't fully understand. We are still uncovering substellar objects that sit right in our backyard. Not because we're missing something urgent, but because the universe moves slowly over immense spans of time, and it hides its smallest residents well. We may find that the number of stars in our neighborhood is actually much higher, populated by cool, dark suns that have been there since the beginning of the Milky Way, waiting to be noticed. And for now, that uncertainty is simply part of the picture. We don't need a final tally of every brown dwarf or dim red dwarf to appreciate the scale. The mystery itself provides a sense of continuity. It suggests that even in the parts of space we think we know best, there is more to be discovered. It doesn't need to be resolved tonight. As we rest in the knowledge of our local street, this small, quiet, suburban neighborhood of 50-odd suns and their invisible companions, we prepare our minds for the next leap. We have counted the houses on our street. Now, it is time to look at the city. We are moving from the dozens to the billions. We are moving from the neighborhood to the galaxy. With that in mind, let's move outward once more, to an even larger scale. Now, let's slowly expand outward. One level beyond our solar neighborhood lies the entirety of the Milky Way galaxy. If our local neighborhood was a single street, The Milky Way is the sprawling, glowing metropolis that contains it. Our galaxy is a barred spiral, a massive whirlpool of stars, gas and dust spanning 100,000 light-years from edge to edge. To traverse it at the speed of a commercial airliner would take you more than 100 billion years, a duration that exceeds the age of the universe itself. Inside this vast structure, the numbers begin to lose their grip on our intuition entirely. Astronomers estimate there are between 100 billion and 400 billion stars in our galaxy alone. To put that in perspective, consider the human heart. Over an average lifetime, a human heart beats about 2.5 billion times. You would need 160 human lifetimes to reach the number of stars in our galaxy, heartbeat by heartbeat. Scientists understand the scale of the Milky Way by measuring the speed at which stars orbit the galactic center. By observing how fast the stars on the edge are moving, we can calculate the total mass required to keep them from flying off into the void. This calculation tells us that the Milky Way is not just a collection of lights, but a massive gravitational anchor. Most of these 400 billion stars are, again, the small red dwarfs we discussed in the neighborhood. But as we move toward the galactic center, the density increases. The suburbs where we live are quiet, but the downtown of the galaxy is a crowded, violent place where stars are packed so closely together that the night sky would be as bright as the day. What we know so far suggests that our sun is just one average star, located in a quiet, unremarkable arm of the galaxy called the Orion Spur. But even with everything we've learned, there are still things we don't fully understand. We don't know the exact number of stars in our own galaxy, and we likely never will. The reason for this is extinction, not the biological kind, but the cosmic kind. The Milky Way is filled with vast clouds of gas and interstellar dust. These clouds act like a thick fog, blocking our view of the other side of the galaxy. When we look toward the center of the Milky Way, we see a wall of darkness. Astronomers must use radio waves and infrared light to see through this fog. But even then, millions of stars remain hidden from our view. What makes this strange is that we are trying to count the residents of our own house while standing in a dark hallway with a flickering flashlight. Beyond the flat disk of the galaxy lies the halo, a spherical region that surrounds the Milky Way like a ghostly envelope. This halo contains globular clusters, which are ancient, tightly packed balls of stars. Some of these clusters contain 1 million stars in a space only a few dozen light-years across. They are some of the oldest objects in the universe, remnants from the very beginning of the galaxy's formation. Astronomers didn't expect these clusters to be so stable. They have survived for over 12 billion years, orbiting the galaxy like moths around a street lamp. But the number of stars in the halo is difficult to pin down. There are rogue stars out there as well, stars that have been kicked out of the galactic disk by gravitational interactions and are now drifting into the intergalactic void. Are they still part of the Milky Way? Or have they become citizens of the nothingness? And for now, that uncertainty is simply part of the picture. Whether there are 100 billion stars or 400 billion, the result for the human mind is the same, a sense of profound, quiet insignificance. It doesn't need to be resolved tonight. We can accept that we live in a city so large that we haven't even seen most of the buildings. The Milky Way is our home, but it is a home of such scale that we are like a single ant in a skyscraper. The 400 billion stars are not just numbers, They are potential suns, potential solar systems, and potential histories. They are the backdrop of our existence, the massive structure that holds our little solar neighborhood in place. As you contemplate the 400 billion lights of the Milky Way, let your breathing slow. Imagine the galaxy spinning slowly, majestically taking 230 million years to complete a single rotation. We are currently on a journey around the galactic center, traveling at 500,000 miles per hour, yet the galaxy is so large that we feel perfectly still. With that in mind, let's move outward once more, to an even larger scale. Now, let's slowly expand outward. One level beyond our galaxy lies the local group. This is a collection of about 50 to 80 galaxies that are gravitationally bound together. While 400 billion stars in the Milky Way seemed like an ending point, it was actually just the beginning. In the local group, the Milky Way has a sister, the Andromeda Galaxy. Andromeda is larger, more massive, and contains an estimated 1 trillion stars. A trillion. That is a 1 followed by 12 zeros. If you were to count to 1 trillion, one number every second, you would not finish for 31,700 years. You would have started counting during the last ice age, before the invention of agriculture, and you would only be finishing today. Scientists understand the local group by tracking the motion of these galaxies as they slowly dance around one another. Despite the expansion of the universe, the Milky Way and Andromeda are actually moving toward each other. They are falling into each other's gravitational embrace at a speed of 250,000 miles per hour. What we know so far suggests that in about 4 billion years, these two giants will collide and merge to form a single, even larger galaxy, often nicknamed Milkomeda. This collision won't be a violent crashing of stars. Remember how much empty space there is, but a slow, beautiful blending of two massive stellar populations. The number of stars in our immediate vicinity will effectively double, but even with everything we've learned about our local group, there are still things we don't fully understand. Scattered between the Milky Way and Andromeda are dozens of dwarf galaxies. These are tiny galaxies, some containing only a few million stars. They are the pebbles scattered around the two boulders of our neighborhood. Many of these dwarf galaxies are so dim and diffuse that we are only just finding them. They are being slowly cannibalized by the Milky Way and Andromeda, their stars being stripped away and added to the larger galaxies' totals. This challenges how we think about the number of galaxies. Is a dwarf galaxy still a galaxy if it is being torn apart? How many of these tiny neighbors are still hiding in the glare of the larger ones? The local group represents a boundary. Beyond this group, the expansion of the universe is pulling galaxies away from us. But within the local group, gravity has won. We are tied to these other galaxies for the rest of time. The trillions of stars in Andromeda, the billions in the Triangulum galaxy, and the millions in the dwarf clouds, they are all part of our cosmic tribe. And for now, that uncertainty regarding the total number of members in our group is simply part of the picture. It doesn't need to be resolved tonight. We are part of a family of galaxies, a small cluster of light in a much larger dark. As you drift further into this thought, imagine the local group as a cluster of campfires in a vast, dark tundra. Each campfire is a galaxy, and each spark in that fire is a star. There are millions of sparks, all huddling together against the encroaching cold of deep space. With that in mind, Let's move outward once more, to an even larger scale. Now let's slowly expand outward. One level beyond our galaxy lies the local group. This is our cosmic neighborhood on a grander scale, a collection of about 80 galaxies huddling together in the dark. If the Milky Way was a city, the local group is the county. It spans about 10 million light-years across. Most of the members are dwarf galaxies, small clusters of a few million stars, but the group is dominated by two giants, our Milky Way and the Andromeda Galaxy. Andromeda, also known as M31, is our closest major neighbor, located 2.5 million light-years away. While the Milky Way is impressive with its 400 billion stars, Andromeda is a true behemoth. Estimates suggest it contains 1 trillion stars. A trillion is 1,000 billion. If our galaxy is a city, Andromeda is a sprawling megastate. Scientists understand the local group by tracking the redshift and blue shift of these galaxies, the way their light changes as they move. What we know so far suggests that despite the overall expansion of the universe, the Milky Way and Andromeda are actually moving toward each other. They are locked in a gravitational dance that will eventually lead to a collision. But because stars are so far apart, as we learned in our human-scale anchors, the stars themselves will likely never hit each other. Instead, they will pass through like ghosts, eventually settling into a new, massive elliptical galaxy. The number of stars in our immediate clump will double, creating a sky filled with a density of light we can barely imagine. But even with everything we've learned, there are still things we don't fully understand about the local group. For years, computer models of the universe predicted that there should be thousands of small, satellite galaxies orbiting the Milky Way and Andromeda. However, when we look through our telescopes, we only find a few dozen. This is known as the missing satellite problem. Astronomers didn't expect the neighborhood to look so empty compared to their theories. Are these galaxies made of dark matter and thus invisible to our eyes? Or have they been swallowed up by the giants already? What makes this strange is that the more we look, the more we realize that our count of total stars in the local group is likely missing millions of residents who live in these dark, diffuse dwarf galaxies. These are the rural areas of our cosmic county, vast spaces where stars are few and far between, hidden in the shadows of the giants. The local group is our final anchor in the sea of expansion. Every galaxy beyond this group is moving away from us, pushed by the mysterious force of dark energy. But here, within the local group, we are held together by the familiar force of gravity. The trillions of stars in Andromeda and the billions in our own Milky Way are our permanent companions in the dark. And for now, that uncertainty about the missing satellites or the exact star count in Andromeda is simply part of the picture. It doesn't need to be resolved tonight. We are not alone in the void, we are part of a small, huddling family of galaxies. And so the universe continues, expanding, cooling, changing slowly, quietly, endlessly. The curvature of space remains, a silent map of everything that has ever been. The light of long-dead stars continues to travel, following the gentle dips and valleys of gravity across the dark. You don't need to stay awake for this part. The universe will still be here, moving gently forward, long after this moment passes. In this final phase of our journey, we recognize that there is no true ending to the story of gravity. It is a narrative that loops and stretches, but never truly breaks. Think of the atoms that make up your body, the carbon in your heart. the calcium in your bones. Those atoms were once part of a star that collapsed under its own weight billions of years ago. Gravity pulled that star together, and when it had served its purpose, gravity helped scatter its remains across the void, only to gather them again to form our sun and our earth. This is the ultimate recycling program. You are not just a spectator of the universe. You are a participant in its endless physical rehearsal. As we look toward the furthest horizons of time, we see a universe that is becoming increasingly diffuse. The galaxies we spoke of, those glowing ornaments on the cosmic web, are drifting further and further apart. In trillions of years, the night sky, as seen from Earth, if Earth still exists, will be much darker. The distant galaxies will have moved beyond our light horizon, their gravity no longer able to reach us across the expanding gulf. But even then, the local gravity of our own group of galaxies will hold us together. We will be a small, warm island in an increasingly quiet sea. Over immense periods of time, this island will also change. Stars will burn through their last reservoirs of hydrogen. They will cool and dim, turning into white dwarfs, then black dwarfs, cold, dense cinders of what they once were. Gravity will still be there, holding these cold remnants in their orbits, patient as ever. It does not require light to do its work. It does not require heat. It only requires mass, and mass, in some form, persists. Even in the deepest, coldest future imaginable, the geometry of space will still bear the imprint of what was once there. There is a profound comfort in this permanence. We live in a world of fleeting moments of sunsets that last minutes and seasons that last months. But gravity operates on a scale of forever. It is the one thing you can truly leave behind. The structures we build, the words we speak, and the memories we create are all subject to the erosion of time. But the gravity of the Earth is a constant. The way the sun warps space-time is a constant. It is a legacy written into the very fabric of the vacuum. As you drift now, let the repetition of the universe's cycles become your own rhythm, expanding, cooling, gathering, falling. These are not just events in space, they are the natural movements of reality. Scientists understand this infinite ending not as a stop, but as a transition into a lower state of energy. The universe is not breaking, it is merely resting. It is finding its most stable, most comfortable shape. Just as you are finding your most comfortable position in bed, the cosmos is settling into its long-term architecture. We often misunderstand gravity as a force of tension, but it is ultimately a force of resolution. It wants to bring things together. It wants to close the gaps. It wants to find the center. In this sense, gravity is the ultimate expression of peace. It is the end of the journey. When a star collapses, it is finally finding the density it has been seeking for billions of years. When a planet settles into orbit, it has found its path. When you settle into sleep, you are allowing gravity to finally win the tug of war it has been playing with your muscles all day. You can feel that victory now. It is in the heaviness of your limbs. It is in the way the mattress seems to rise up to meet you. You are no longer fighting the 9.8 meters per second squared. You are accepting it. You are trusting the Earth to hold you, just as it holds the atmosphere, just as it holds the oceans, and just as it holds the moon. You are in very good hands. The mass of the entire planet is dedicated, in this moment, to keeping you exactly where you are safe, grounded, and still. Across the vast distances of the deep drift, the same process is occurring. Across the billions of light years of the cosmic web, the same process is occurring. The universe is not in a hurry. It does not need to arrive anywhere. It is already there. Astronomers didn't expect the universe to be so quiet at its largest scale. They expected a roar, but they found a hum. They expected a struggle, but they found a dance. What makes this strange is how perfectly it fits within our own experience. We are microscopic versions of the cosmic process. We expand in our youth, we cool in our wisdom, and we eventually seek the rest that gravity offers. It is a beautiful, inevitable symmetry. And so, we leave the questions for another time. We leave the how and the why to the scientists of the future. For tonight, we only need the is. The universe is expanding. The universe is cooling. The stars are in their places. The curves are steady. The weight of the world is not something you need to carry. The world carries itself. The stars carry themselves. Gravity will keep everything in its place. It will keep the air around you. The weight, it will keep the earth beneath you. It will keep the stars in their slow, rotating dance. Everything is exactly where it needs to be. You don't need to stay awake to witness the continuation. The process is automatic. The architecture is sound. You can let go of the thread. The web will not break. The loom will not stop. The waltz will not end. And somewhere within all of this, we can begin again by starting with something familiar, the weight of a heavy book in your hand, the way your feet press into the floor, the gentle, persistent pull of home, expanding, cooling, falling into the dark, falling into the rest, safe, held, constant. The universe does not require a final chapter because it is a cycle of infinite continuity. Even as we speak of endings, gravity is already preparing the next beginning. In the cold, quiet corners of the distant future, the very same forces that sculpted the mountains of Earth will still be at work, drawing together the remnants of light to create something new. When we think about the infinite ending, we often imagine a stopping point, a wall at the end of a hallway. But in cosmology, the end is simply a change in density. Imagine a star that has lived for 10 billion years. When it finally exhausts its fuel and sheds its outer layers, it does not simply vanish. It becomes a white dwarf, a dense, glowing ember held together by the same gravity that birthed it. Over trillions of years, that ember will cool until it becomes a black dwarf, a cold, solid diamond of matter floating in the dark. It is still there. It still has mass. It still curves the space around it. Gravity is the memory of the star, persisting long after the light has faded. Scientists understand this persistence by looking at the heat death of the universe, not as a fiery destruction, but as an ultimate state of rest. It is the moment when all the energy has found its level, when the temperature of the cosmos is perfectly uniform. In this state, there is no more work to be done. There is no more struggle. It is the ultimate sleep of the cosmos. But even in this state of maximum entropy, gravity remains the foundational law. The structure of space-time, though stretched thin by dark energy, still carries the signature of every galaxy that ever was. The geometry is eternal. Historically, we have always been obsessed with the idea of a big crunch or a big bang, a definitive start and stop. There is a gentle, scale-based humor in our need for a deadline. We want the universe to follow the same schedule as a workday or a harvest, but the universe is more patient than our calendars. It moves through phases of expansion and contraction, of cooling and gathering, in a way that makes the concept of an ending feel like a human misunderstanding. Gravity is the bridge between these phases. It is the force that survives the death of one era to seed the birth of the next. Consider the loop-safe nature of our existence. Every atom in your body has been recycled through the hearts of at least 2 different generations of stars. You are made of stardust that was pulled together by gravity, dispersed by a supernova, and pulled together again to form the Earth. This cycle has no beginning and no end. It is a continuous loop of matter and energy, governed by the same curvature of space. When you close your eyes and feel the heaviness of sleep, you are experiencing the same surrender to the curve that a star feels at the end of its life. It is a return to the baseline. At this final scale, the language of the script becomes a series of echoes, expanding, cooling, changing slowly, changing quietly, changing endlessly. The repetition is not a lack of new information. It is the presence of a fundamental truth. The universe is a repeating pattern of gravity and space. Whether we are looking at the fall of an apple or the collision of 2 supermassive black holes, the music is the same. It is a low, steady vibration that resonates through every atom. You can lean into this vibration. You can let it carry you away from the sharp edges of individual thoughts and into the smooth, repeating loops of the infinite. Astronomers didn't expect the universe to be so remarkably consistent. They expected to find places where the laws of physics broke down, where gravity stopped making sense. But everywhere we look, from the edge of the observable horizon to the center of our own planet, the rules hold. The anchor is firm, the waltz is steady, the loom is weaving, the web is intact. This consistency is the ultimate gift of the cosmos. It means that we are never truly lost. No matter how far we drift into the dark, we are always within the reach of the law. As you move into the final minutes of this journey, the gravity of your room becomes the gravity of the stars. The weight of your blanket becomes the pressure of the atmosphere. The stillness of your mind becomes the silence of the vacuum. You are no longer trying to understand gravity. You are simply allowing it to be. It is the force we completely misunderstand when we try to fight it, but it is the force we perfectly understand when we finally let go. Not because we're missing something urgent, but because the universe is already complete. The expansion is happening as it should. The cooling is happening as it should. The falling is happening as it should. You are exactly where you need to be in the center of your own gravitational well, surrounded by a universe that is both infinitely large and intimately close. And for now, that uncertainty is simply part of the picture. It doesn't need to be resolved tonight. The universe will still be here, moving gently forward, long after this moment passes. You can drift now. You can fall into the dark. You can fall into the rest, safe, held, constant. And somewhere within all of this, we can begin again by starting with something familiar. The weight of a heavy book in your hand. The way your feet press into the floor. The gentle, persistent pull of home, expanding, cooling, endlessly, endlessly, endlessly. The curve is smooth. The weight is warm. The drift is eternal. You are part of the continuity. You are the breath of the vacuum. You are the mass of the stars. Sleep is the gravity of the mind, and the gravity is perfect. Good night.